The manufacturer, by observing the front view, side view, and top view, they are going to manufacture the component. And to know how actually it looks, they require the isometric projection. So isometric projections are nothing but a three-dimensional object which are produced in a two-dimensional plane. So this one example. So coming for next example, so the computer, and if you go for a building drawing. So building drawing, you can observe the second figure here. In a building drawing, what you can say, okay, this is the dimension. So actual dimension of this, they're going to get only in the front, side, and top, which is called as orthographic projections. But you can look at this figure, it is a isometric projection. Okay, only the view, how actually it will be, that we can see in the isometric projection. Actually, it is not required for manufacturing. For manufacturing or for producing anything, you require the orthographic projections. So front view, side view, top view. There, you're going to get the actual dimension. By using this actual dimension only, a manufacturer or industrialist, they can manufacture something. But to know how it looks, you require the isometric projection. So when these three front, top, and side is clubbed together, this is the view, and this view, it shows how actually it looks. This is called as an isometric projection. So this one example. So front view, side view, top view. What is its length? What is its depth? So everything you can find from seeing its orthographic projection. And so this is the isometric projection. So now there are three types. One is isometric projection, diametric projection, and trimetric projection. Okay, but according to our syllabus, we have only isometric projection. Iso means equal, metric means angle. So equal angle or equal inclination is called as isometric projection. So you can observe here, we have x-axis, y-axis, and the z-axis. All the three axes are there. Nothing but is a three-dimensional figure here. So having equal extent, three equal axes and three equal angles. So x, y, z, and angles are same. In a diametric, so two angles will be same and the two dimensions will be same. So two equal axes and two equal angles will be there, and one angle will be different and one side will be different. The last one, trimetric, where we have zero equal axis and a zero equal angle. So all the sides and all the angles are different. So 110, 130, 120, x-axis, y-axis, z-axis. All the lengths and angles are different. This is called as trimetric. So this is only for your information. But for our syllabus, we have only this isometric projection. Okay. Now, how actually this isometric projection or isometric drawings can be drawn? So first you need to draw a 30-degree line on both the sides. So first you need to mark one point and draw 30-degree on both the sides with actual, that is a equal length, and draw one vertical line of same length. So x, y, and z. So x, y, and z, all the three axes what I am taking here, the lengths are same. So for this line, the 30 line what you have drawn, for that draw the parallel line. So same parallel line. Next, the other side, draw the parallel line. Next, what you do, again for this line, draw the parallel line, and for this line, draw the parallel line. So this is how a cube will look. This is a cube. So this is the actual cube. So in this cube, you can observe here, it is a three-dimensional figure. It's an isometric view. So I'll show you how actually this can be drawn. Okay. Now I have a cube of 50 by 50 by 50. So this is the cube having the length 50, width 50, and the breadth 50. So now what I'm showing you is the front view. So the front view, how it looks, the length is 50 mm, height is 50 mm. So this 50 and 50 both are true length. Okay. Now suppose if I rotate this, So now keep like this. Now what you can say, you can see two faces of the cube, the one face and the other face. Two faces of the cube you can see, and having the width as a different one. So the width, it is not equal to 50. So now what you are looking is the front view. In the front view, what you are observing is the two faces you are going to see, two surfaces of the cube you are going to observe here. Height is visible, which is having a true length. But connecting to this, the other two sides, what you're going to see here, those two sides are not having its a true length. Okay. Now, if I want to see the top face also, then what I will do? I'll just incline it to the equal angle. Just rotate like this. Now I can observe here. I just what I made, I just rotated the z-axis. So x-axis, y-axis, and the z-axis, I just made an equal inclination. Now I can see all the three faces, the top face, the side two faces. Okay. Now what I can observe is the height and the width and the length. All the three are not to its true length. It is now converted to isoscale. It is now converted to isoscale. So this is that one. So what I done, just 30 degree, 120 degree, and 120. So next coming to the isometric scale. So this is called as isometric scale, and here you are going to study how actually you are going to draw the three-dimensional diagram in a two-dimensional sheet. That is isometric drawing, how to draw, that you are going to learn here. Suppose if you just take a scale, so the scale, you draw a 45-degree line and mark 10 mm, 20 mm, 30 mm, 40 mm, 50 mm. Okay. Similarly, draw one 30-degree line. Extend 1, 2, 3, 4, 5. That is 10 mm, 20 mm, 30 mm, 40 mm, 50 mm. Just draw one vertical line and name that as 1, 2, 3, 4, 5. Now measure the values. Measure the values. So the length on the 45-degree line is 10 mm. The length on the 30-degree line, it will be converted to 0.8165 into 10. That is 8.165. Okay. So this is called as isometric length. Okay. The actual length, if it is 10 mm, the isometric length will be equal to 8.165 mm. So how it is? So just now I explained you, I showed you one cube which is rotated at an equal angle at all the three x, y, and z axis. So now the actual length is AC1. AC1 is the actual length, and AC is the isometric length. AC1 is the actual length, that is true length, and AC is the isometric length. When you just draw a line, just what you do at A, draw the horizontal line, and this distance or this inclination is 45 degree. And now this distance is, that is inclination is 30 degree. The true length is AC1. The isometric length is AC. So AC1, if it is 50 mm into 0.815 will give this AC value. Okay, it is converted to isometric. So what I'm going to do is, before you start any problem, first compulsory you should draw the 30 degree line on both the sides. When you start solving the problem, you come to know how I should draw. So it's all problem. I'll show you on that. So this sheet I already sent you in a PDF. You can open that. Those who have already the isometric sheets, that is in your sketchbook, you can open that. That is there in your last pages. So last pages you have isometric sheet. So this is called as isometric sheet. So these isometric sheets are already converted and it is printed to isometric scale. So there is no need to convert any values here. So directly you can use the values. So how it looks. So this is actually the enlarged figure of a isometric sheet. Okay. So in this enlarged figure, you can observe here all the lines are drawn at an angle of 30 degree, 30 degree. All the lines are already drawn at an angle of 30 degree and 30 degree. And if you measure the length, breadth and width and height, everything, if you just measure, we're going to observe the length, height and all, it is converted to ISO scale, that is 8.16 mm. The actual value is 10 mm, but ISO 10 means 8.16. So these sheets which are provided are already converted to ISO scale. So there is no need to go for conversion. So drawing the ISO scale and all, there is no need. Directly you can start doing the problems. So example, so first one, we have a square of 40 by 40. So square means only one dimension they will give. So ABCD is a square, is having a dimension of 40 mm. So how to draw this 40 mm square in an isometric sheet? So to draw this, first randomly select one point in a isometric sheet. Mark that point as A. Okay. Once you mark this point, on the 30 degree inclination line, you need to measure the dimension. So no need to use your scale, a normal scale, there is no need to use. Just you need to count the box here. Okay, the boxes you need to count. So what is the square dimension they are given? The square dimension they are given is 40 by 40. So first I just marked one point and named it as A. Okay, on the right side, I'll count 4 boxes. I'll count 4 boxes and I'll draw the line. 4 boxes and I'll draw the line. And I name it as B. So I'm drawing this square in the horizontal position. I can draw the square in vertical position or horizontal position. So now what I'm drawing is in the horizontal position I'm going to draw. So first I just mark one point. From that point on the right side, I measured 4 boxes and drawn the line. So next what I will do, I'll measure another 4 boxes and I'll draw the line and name the point as C. Okay, so I got point A, point B, point C. So next you can observe C to D and A to D. So C to D is a line which is parallel to A to B, and A to D is a line which is parallel to B to C. So just what you do, draw the parallel line at that points, so that you are going to get ABCD square. Suppose some problems, they may ask you to construct a square in a vertical position. A problem. Then how to draw a square in vertical position in isometric. So what I do, first I mark one point A. Next, similar to the previous, just I go to count 4 boxes and I mark point B. Next, instead of counting on the 30 degree inclination line, I'll go vertically. So vertically, I'll count 4 and I'll mark the point as D. Next, we got point A, B and D. You can observe from the actual figure A, B, D. So for AB, line DC is parallel. For AD, line BC is parallel. So what you do, just draw 2 parallel lines and complete the figure. So this is a vertically drawn isometric square. Similarly, you can draw this square on the one more method. So vertical square left side, vertical square right side, and horizontally. So this is how we can construct a square in a three different manners. So based upon the question, you're going to select whether to draw vertically in the right side or vertically in the left side, or we need to draw the horizontal. So this is one polygon. So we come for a rectangle. So square means all the sides were equal, it was easy. So now what the given is? It is a rectangle of 30 by 20. So first step what I'll do, I need to select one point, a reference point. So either you can take the reference point as A or B. That is bottom. You need to select the bottom only. Either take the left side bottom or right side bottom. Anyone you can select. So now I'm explaining with taking the left side. That is A. So first randomly I'll select one point. Name it as A. Next, I need to draw B. Okay. So to draw this B, what I will do, I'll measure two boxes on the 30-degree line and name it as B. Next, again horizontally I'm going to draw this rectangle box. So measure three boxes and name it as C. 1, 2, 3 and name it as C. So now again we got A, B and C. So C to D distance is 20. So parallel to this draw 20. And A to D parallel dot and we're going to get 30 and 20. Name it. So this is horizontally drawn rectangle box. So I'm just explaining you how to draw the polygons, different polygons. So once you go for solving the problems, you'll be benefited if you're thorough with this actual polygons, regular polygons. So I'm going to draw vertical. So how to draw vertical? So first mark one point as A. So I'll count two boxes and then draw one line, name it as P. Next, instead of going on the inclination line, I'll go vertically. So vertical I'll count three boxes on both the sides and I'll draw the parallel to complete the rectangle box on the right side. Okay, vertically placed. Similarly on the left side, I can draw it. Okay. Now coming for the circle. So drawing a circle to its isometric, it is having different technique. So that technique is called as 4-arc method. By using 4-arc method, we're going to draw a circle. Circle will not be a circle in isometric view. So it will be other than circle, just like an ellipse. Okay? Because it will not be to its actual dimension. There is a change. The method used in this is called as 4-arc method. So first thing what I'll do, I'm going to construct a square of 50 by 50. First, I need to construct a square of 50 by 50. For that purpose, what I'm going to do is, I'll just mark one point and from that point, I'll count 5 boxes on the right side and 5 boxes on the left side. And I'll construct a square of 50 by 50. What I've done is, I just constructed a square of 50 by 50. In this square, I should draw the circle. So for that purpose, what you should do is, you need to select any two opposite points. Any two opposite points. Okay. So I just chosen the 2 points here, opposite points. Next, you need to select 2 opposite lines for the point. So I just named it as C1 and C2. So 2 points I have just taken. 2 lines I have taken and I have chosen the center. So for C1, we have the opposite 2 sides. We need to select the center of this. Select the center of this. That is at 25 mm, mark one point. At 25 mm, mark one point. Similarly, for C2, the opposite lines, you need to mark the center. That is 2.5 and 2.5. Join it. Okay. From C1 to opposite sides, center join it. From C to opposite sides, center join it. Okay. Now the intersection mark as a point, and I'm going to name it as C3 and C4. Now the point I'm going to name it as R1, and here I'm going to name it as R2. So with the C1 as center and R2 as radius, I'm going to draw one R. So I'm going to get a smooth curve with C1 as center and R1 as radius, draw one curve. Then with C2 as center and R2 as radius, draw one curve. Similarly, with the C3 as center, R1 as radius, draw one curve. C4 as center, R2 as radius, draw one more curve. So this is how you can draw a circle in its isometric view. Similarly, we can draw the circle vertically. So for that purpose, I'm going to draw a square of 50 by 50 in the right side vertical position. Next, I'm going to select any two opposite points. After selecting the two opposite points, you need to select the two opposite lines center. Next, the other two side opposite centers. So mark the center points and join with a line. Next thing, you need to mark the intersection of the two lines and name it as C3 and C4. So I got four centers here, C1, C2, C3 and C4. So I'm going to name the radius R1 and R2. With C1 as center, R1 as radius, I will just draw the arc. With C2 as center, R2 as radius, I will draw one more arc. Similarly, with the C3 as center, R1 as radius, C4 as center, R2 as radius, I will draw other arcs. That will complete the circle in its vertical position on the right side. Similar to this, you can draw it on the left side by constructing a square of 50 by 50 on the left side. So now what you should do is, you need to select any two opposite points. Name the points as C1, C2. Next thing, select two opposite lines and mark its center for both the points C1 and C2. Draw the lines from that particular point. Now, with the C1 as center, R1 as radius, draw the arc. With the C2 as center, R2 as radius, draw the arc. Similarly, C3 as center, R1 as radius, C4 as center, R2 as radius. So this procedure is called as 4-arc method. So these are some of the simple polygons, regular polygons that we'll be using in the drawing. So now to construct a pentagon. So how you can construct a pentagon? So for constructing the pentagon, so first you need to draw the regular pentagon. You know how to draw a regular pentagon. So with the actual procedure, first draw the regular pentagon. Once you draw the pentagon, the next step is to connect the points and make it like a box. So what it is done here is, so first we draw a pentagon, extended the line horizontally, extend the line horizontally on both the sides, and here also from this tip I just draw the horizontal line and draw the vertical line passing through the point. I just draw the point. Like this, a box is prepared. and this box named as 1, 2, 3, and 4. Okay, and we need to measure the distance from all the points. Okay, so 1 to A, the distance is 9. So B to 2, the distance is 9, and the vertical height distance is 46. The horizontal distance is 48. Next, from point 2 to point C, the distance is 28. From point 3 to point C, the distance is 18. Similarly, from point 3 to D, it is 24. So like this, first you need to draw the regular pentagon and mark all these dimensions on this regular pentagon. Once you mark all this, the next step will start. So what we should do is, you need to first mark one point and mark one point as 1. So the distance which is to be taken on the right side is 48. So from 1, these are 48. So 48 means exactly that 48 you can't write. So approximately. So one box is equal to 10 mm. Okay. So isometric value. So 10, 20, 30, 40, and 50. But it is 48. So less than 50 is at some distance. At some distance, mark one point and name it as 2. So here you are going to write the approximate value. You're not going to use any scale here. So counting the box is important. Okay. Next. So this I have drawn on the right side. Now from 2 to 3, the distance is how much? It is 46. So 1, 2, 3, 4, 5. 5 means 50. So less than that. So you can observe in your isometric sheets, if you have a sketchbook, if you open and say, there will be the line which is drawn at the center. You can easily identify where is the center of that box. So 45, it is easy to draw. 55, easy to draw. 10, 15, 20, 5, okay, it is easy to draw. They are mentioned already. Where exactly the 5 come. 1 or 2 means just you need to approximately draw. So now what I done? I just drawn 46. So 2 to 3, the distance is 46. I am marked 46. Next, I'll draw 3 to 4. So 3 to 4 distance is how much? It is 48. So I'll draw 14, 40. So it is nothing but a parallel line. So for 1 to 2, 4, 3 is a parallel. For 2 to 3, 1, 4 is parallel. So measure and connect like a rectangle box. Because it is 46 by 48. So just like a rectangle box, I just made it. Now we can observe from 1 to 2. From 1 to 2, we have 2 points. One is A and one is B. So for that purpose, what I'll do, I'll see the value here, 9. So A is located from 1 at a distance of 9. So first box into ಸ್ವಲ್ಪ ಕಡಿಮೆ ಜಾಗದಲ್ಲಿ you need to mark the point as A. Not exactly on the line, less than that, because it is 9, not 10, it is 9. Similarly, from 2, should mark B. Next, on that line 2 to 3, 2 to 3, we have point C. This point is located at a distance of 28 from point 2. So 28, 1, 2, 2.5. So here, somewhere here, I'll get point C. Mark point C. Next, from 3 to 4, at a distance of 24 from 3, we have point A. So what I'll do, from 3 to 4, 24 distance. 20, 10, 20. So less than 25, we have 24. Mark point D. Next, between 4 to 1, I have point E. The distance is same as this, so that is 18. From 4 at a distance of 18. So 1, 15, 18. Mark point E. Connected. A to B, B to C, C to D, D to E, E to A. So this is a pentagonal lamina. So this is a pentagonal lamina. So like this, you need to construct hexagonal lamina. So how to construct hexagonal lamina? So first you need to draw the hexagonal lamina. So this is a vertical one, pentagon vertical portion, pentagon vertical on the left and right side, hexagonal lamina. So first, how to draw this hexagonal lamina? You need to first construct the hexagonal lamina. Next, you need to connect the points. So what you do? Draw the horizontal line, draw the vertical line. Okay. Now, next what you do? You need to name it. So this one I named as 1, and here I named it as 2, and here I named it as 3, and here I'm going to name it as 4. 1, 2, 3, 4. Similarly, here I name it as A, B, C, D, E, and F. So I'll write this. Next, what you should do is you need to write the dimension of 1 to 2. What is the dimension? So 1 to 2, what is the dimension? You write the dimension here, 1 to 2. Next, you need to write the dimension 1 to 4. Write the dimension. Okay. Next, what you do? Measure the distance and write what is the dimension of 1 to A, what is the dimension of A to B, B to 2, and here this distance. So here you can observe, so this value and this value will be same, this value and this value will be same, and this value will be same. So only one side you need to mention the dimensions and follow the step which I explained you in the previous problem, that is to draw the pentagon. Similar to that, try to draw this hexagon on an isometric shape. So only draw the horizontal face. No need to draw the vertical one, vertical right side or vertical left side. No need to draw this. So just draw the horizontally placed hexagonal lamina of 25 mm size in your isometric shape. Okay. So this is for today. So I'll end the session here. So try to do this and send me the snaps of all those. Tomorrow morning I'll be starting with the problems directly. So these are very simple problems. We can do it very easily. So tomorrow morning we'll start with the problems.